Hey, my name is Casey, and this is my final project I'm presenting for ECEN 160, and this is the 4-bit microprocessor that I designed. All right, so I just want to take you guys through and go through the overall function of it and how it works. And so first thing first, this is our clock. This is what drives the whole thing because, well, the clock and the counter drive it together. So we have a clock here that's connected to our counter. And our counter is an 8-bit counter, and that is going to just be consistently counting up, and that's going to be the engine powering our PROM. And the programmable read-only memory is containing all of my machine code that I put in here, and that will contain all of the data as well as the direct commands as to the commands that my processor is going to be running, and it's going to be outputting in 8 bits. And as soon as it comes out of the PROM here, I'm splitting it up into 2 different ways. So the first way is taking bits 0 through 3, those 4 bits, and taking it up here to the machine decoder. And then bits 4 through 7, those 4 bits go down to the multiplexer and then get fed into the register. And so I just want to take a moment to talk about bits 0 through 3 that come out of the PROM. To another read-only memory, and this is my, like I said, this is the decoder. This is going to take all of that came from PROM, and it's going to assign those out actually with the specific tasks to each component in the microprocessor, and that's what you see. These 8-bit lines are going out, sending those commands. Now, if we follow out of the PROM for bits 4 through 7, that gets fed into the microprocessor. That gets fed into the multiplexer, which then gets down pushed into the register. And just to clarify, that's 4 bits coming through here, 4 bits in here, and 4 bits in here. Also, going into the multiplexer that's pushed to the register from our ALU is another 4 bits that's coming there, and that will loop around. And so let's just take a moment now to look at what we've done in the register here. And so the basis of this is kind of coming from the lab that we did a while back, down version. But this is the logic for our enable and our 2 4-bit outputs, one for register 1 or register 0 and register 1. And so let's jump in our subcircuit. If it loads, there we go. And this is, again, very simplified down version, though, but this right here, or both of these are a 4-bit register. And we'll jump in there. Our multiplexer and the flip-flop, all 4 of those. Putting out our 4-bit register. And so that's essentially everything in our register here. I want to take a moment to jump to my ALU and look at that. So we have our 4 subcircuits here based on the 8 bits coming from our register, 4 bits from the first register and 4 bits from the second register. And that's being fed into each of our 4 subcircuits. And this is where the magic is going to happen with our arithmetic computing. This is my add and subtract sequence. And then if we jump down further, here we have our 1-bit adder. And this is going to determine whether we're adding or subtracting, and our exclusive OR gates there. So got another subcircuit in our ALU. This is our AND subcircuit in our ALU, and then the OR and the exclusive OR are very similar to that as well. So I'll avoid going into those for time's sake. But just jumping in and running circuit, you can see it's going through gene code I put in there, and it's being fed up through here. You'll see on the display, I believe what it is just a bug in my code I've spent a lot of time trying to find that, and unfortunately I haven't been able to quite figure that out. And so my display doesn't seem to be 100% operable, and it resets, or ampersand, not ampersands, what am I thinking? At symbols, and then it resets. But I believe everything else is assembled correctly, so that leads me to think that it's a problem with my code here. But nevertheless, I hope you liked my presentation and my processor here. Thank you.